Happy Thursday, guys. Welcome back to Algebra 2 Easy. Today, we're going to find trig ratios with special right triangles. Special right triangles are very handy. Please remember that if you do not remember them, we do have a great video on how to get those memorized fairly quickly. A brief recap. Remember, you have a 45, 45, 90-degree triangle. And please know that your legs for this particular triangle are exactly the same length. So we label those as X and X. Now, what's great is that your hypotenuse, which is always across from the right angle, is going to involve X as well. But don't forget, it should be multiplied by radical 2. Now, let's look at a 30, 60, 90 triangle. Again, all of our sides are going to involve X, but let's talk about where X should go and what else goes with it. So across from 30 degrees, remember, it's just X. And then remember, beside 30 degrees, it's going to be X, but then it's also going to involve radical 3. Remember from our video, it said 3 next to 3. That's how you remember it. Now, also remember across from your right angle, which is your hypotenuse, it's going to involve X, but there's also going to be a 2. Notice that your hypotenuse for both have a 2 involved. So that was a quick recap. So let's go ahead and do some practice problems. So let's flip it over. It says triangle MNO is a 45, 45, 90-degree triangle with side length OM equal to 2. And it wants to know what are the 3 trigonometric ratios for angle N with measure theta. We're going to make sure we take it piece by piece. So let's draw a triangle MNO. It's a 45, 45, 90 triangle. So 45 and then also 45. And if you read on, it says that it has a side length where OM is equal to 2. Well, let's label that triangle. And students say all the time, I just don't know where to start with my labeling. It truly doesn't matter. You can erase all you want. I'm just going to put M at the top, then do N, and then do O. And if it doesn't work out, I just start over, okay? So it says OM is equal to 2. So I'm going to put 2 here. Now, what's great, like I said, if you have those special right triangles memorized, you know that your legs are going to be the same length. So if one leg is 2, that means the other leg is 2. Also, you know that your hypotenuse is also going to involve that same length of 2, but radical 2 is going to be next to it. Now, it does want us to find those 3 trigonometric ratios for angle N. So we must use SOHCAHTOA. And remember, it houses our opposite side, our hypotenuse, and also our adjacent side. So let's start labeling. Across from 45 degrees here for N, I see 2. So that's going to be our opposite side. Then if I go back to 45 degrees, I see 2 that's right beside it. If it's right beside it, that's going to be your adjacent side. Then across from the right angle, I see 2 radical 2. And that's going to be my hypotenuse. So then now I'm ready to use SOHCAHTOA and write my 3 trigonometric ratios. So remember, sine, we have opposite and then the hypotenuse. So let's talk about the opposite side for us. We have it labeled, it's 2, and then the hypotenuse is 2 radical 2. So this is going to be 2 over 2 radical 2. Now, we would be finished, but you do have a radical in the denominator, and you cannot leave. Simplify, 2 divided by 2 is 1, but we still have that radical 2 in the denominator. If you simplify that, you're going to get radical 2 over 2. Now, let's talk about cosine. Cosine, we know we have the adjacent side and then also your hypotenuse. So if you go back to angle N, we have an adjacent side that we have labeled of 2, and then we also have our hypotenuse of 2 radical 2. So again, 2 for adjacent, and then 2 radical 2 for your hypotenuse. Now what's great is that we've already simplified this fraction for our sine function. So we're going to have radical 2 over 2 again. And that should make sense because think about it. The side lengths were exactly the same. Talk about tangent. Tangent has the opposite side and the adjacent side. So if we look, here's our opposite of 2, our adjacent of 2. So that's going to be 2 over 2, which makes 1. So our trigonometric ratios is going to be sine of theta is equal to radical 2 over 2. Cosine of theta is equal to radical 2 over 2. And then last, you have tangent of theta, and that is equal to 1. Now, our next example involves a 30, 60, 90 triangle. So let's go ahead and draw that triangle. It says triangle JKL. Again, it doesn't matter where you start when you put J at the top again, and then K, and then L. It is a 30, 60, 90, and then it says it has a side length for LK to be 4, and then angle J to be 30. So since they want 30, I'm going to put 30 for J, and then 60 has to be for K then. It tells you that LK is 4, so we're going to put 4 here. And then we need to fill in the rest if we're going to find those trigonometric ratios. So please remember that each side is going to involve x. And since you have it memorized, you know x is always across from 30 degrees. So 4 is going to be on every side. However, there's a little bit more to it. Because remember, right beside 30 degrees in our special right triangles, we have a 3. So remember, it was x times radical 3. So it's going to be 4 times radical 3. Now also remember, our hypotenuse for a 30, 60, 90, it involved more than x. Remember, it was 2 times x. So if x is 4, if we multiply by 2, that's going to make our hypotenuse to be 8. Okay? So I'm going to erase that. That way it's not in the way. But again, our hypotenuse should be 2 times 4, which is 8. So if we go to angle J here, let's go ahead and label our sides. So notice that 4 is opposite from 30 degrees. So I'm going to put OPP. Now, if we look at 4 radical 3, it is right beside 30 degrees. So that's your adjacent side. And then if you look, across from the right angle is 8. So that's going to be your hypotenuse. So now you are ready to use SOHCAHTOA. So let's do sine first, opposite, and then also your hypotenuse. So look at what we have as our opposite side. We have 4 labeled, and we have our hypotenuse of 8. So that's going to be 4 over 8, which we know simplifies to 1/2. So sine of theta is equal to 1/2. Now, let's talk about cosine. Cosine is going to be your adjacent side over your hypotenuse. So we have our adjacent side labeled as 4 radical 3, and our hypotenuse is still 8. So it's going to be 4 radical 3 over 8. Now, a radical in the numerator is fine all day long. Okay, so we just need to simplify 4 divided by 8, which simplifies to 1/2. So it's going to be 1 radical 3 over 2. Now we're going to move on to tangent of theta. Remember, tangent involves the opposite side and the adjacent side. We have 4 labeled as opposite, and we have 4 radical 3 labeled as adjacent. So it's going to be 4 over 4 radical 3. Now, we definitely can have a radical in the denominator, but we can simplify 4 over 4 first, which is 1. So it's going to be 1 over radical 3. And then remember, 1 over radical 3 can definitely be simplified to radical 3 over 3. And then that's it. Now, I do have 2 triangles for you to try. They're both 45, 45, 90, but they're definitely good problems. Great practice. If I were you, I would pause the video. Get stuck, you can always just go back, rewind, and see where you need to pick up. But then, once you're finished, keep playing because I have the answers after this. I hope this was helpful, and I hope you have a great Friday.